All right, let's dive in. Today we're pulling back the curtain on the secret rules that connect, well, pretty much everything. We're talking about relations and functions. It's going to be a wild ride, starting with total chaos and ending up with perfect, beautiful predictability. You ready? Let's go.
I mean, just think about it for a second. Your social media, that connects you to your friends. A family tree, that connects generations. Heck, even a weather app connects something like air pressure to the chance of rain. All of these are just connections, right? But how do we actually talk about them in a way that's, really useful and precise?
And once you start looking, you see these connections everywhere. You've got brother and sister, parent and child, teacher and student. All of these are basically just pairs of people, right? And they're linked together by some kind of rule that we can all understand.
And this is where math swoops in to save the day. It gives us this really powerful, super precise language to describe all these links. And the very first step on this whole journey is to just imagine. Imagine every single possible connection that could ever exist between two different groups.
Okay, so we're starting in this world of pure what if. A world where we're going to create every single combination we can possibly think of, just to lay it all out and see what we've got.
So let's imagine we've got two simple groups. In math, we call them sets. Set A has just two colors, red and blue. And set B has three things, a bag, a coat, and a shirt. Our mission, should we choose to accept it, is to create every possible colored object we can by pairing one thing from each set. Now, this whole process of making all the possible pairs has a fancy name. It's called the Cartesian product. You'll see it written as A cross B. And here's the really important part. These are ordered pairs. That just means the thing from the first set, or set A, always comes first. So we'll get a pair like red bag, but we'll never get bag red, because bag just isn't in our first group of things.
And voila, here they all are. Every single possible pair. You got your red bag, red coat, red shirt. Then you've got your blue bag, blue coat, blue shirt. 6 different possibilities. That's it. This table, this is basically the entire universe of connections between our two little sets. And you know what the best part is? We don't even have to write them all out to know how many pairs there are. Nope. We can just multiply the number of things in set A, which is 2, by the number of things in set B, which is 3. And boom, 2 times 3 gives us 6 possible pairs. It's a super simple but really powerful shortcut. Okay, so now we've got this huge pool of every possible pair. But let's be honest, most of these pairings are totally random. The next step is to sift through all this chaos and find the connections that actually mean something. And how do we do that? We introduce a rule.
And that brings us to our first really big idea, a relation. A relation is, well, it's just a selection, or a subset if you want to get technical, of all those possible pairs we just made. It's the special group of pairs that actually follow a specific, meaningful rule that we just decided on.
Let's check out another example. Imagine we're pairing letters with names. Now, if our rule is the letter is the first letter of the name, then we'd only pick out these specific pairs. We'd grab A, Ali, B, Banu, B, Binoy, and C, Chandra. See what we did there? We just filtered out all the nonsense pairs like, say, a Binoy, and we created a meaningful relation. All right, now we get to the real heavyweight, the most powerful, most precise, and most predictable type of connection in all of math. This is where we lay down the law with the strictest rule of all.
And here it is, the moment of truth, a function. A function is a super special kind of relation, but it has one extra, absolutely non-negotiable rule. For every single input from that first set, there can be one and only one possible output in the second set. One input, one unique output. No exceptions, every single time.
This image just nails the difference. Over on the left, that's a function. See how each input 1, 2, 3 points to exactly one output? Clean and simple. But on the right, that is not a function. Because if our rule is the square root of, the input 9 points to 2 different outputs, 3 and -3. And that totally breaks our one and only one rule. Game over.
Here's a really great way to think about it. A function is like a perfect vending machine. You press the button for espresso, you always get an espresso. You never ever get a latte by mistake. If you press that button and sometimes a latte came out, well, that machine would be broken, right? It wouldn't be functioning properly. It wouldn't be a function.
So, now that we've got a handle on what a function actually is, let's take a quick tour and meet some of the all-stars, the most famous functions you're gonna run into.
Think of them like characters, each with its own special personality. First up, we've got the simplest one of all, the identity function. Seriously, whatever you put in, you get the exact same thing out. Put in a 5, you get a 5 out. It sounds almost too basic, but it's actually a super important baseline in math. It's like a perfect mirror.
Next up is the constant function. And this one is the definition of predictable. No matter what you put into it, the output is always the exact same constant value. Always. It's kind of like a fixed price on something. Doesn't matter who's buying, the cost is always the same.
Ah, here's a classic I bet you've seen before, the square function. All this one does is take the input and multiply it by itself. And this function is famous for creating that beautiful, symmetrical U-shaped curve. You know the one, the parabola, when you draw it out on a graph. And finally, let's talk about the modulus function, or as you might know it, the absolute value function. Its whole job is just to tell you how far a number is from 0, which means the output is always positive. Since -3 and 3 are both the same distance from 0, the graph kind of reflects back up, making this really cool, distinctive V-shape. So we've gone on this whole journey, right? From just random pairings all the way to these super specific functions. But why does any of this actually matter? Okay, let's get into our final section and see how all this abstract math stuff really builds the world around us.
The short answer is functions are literally everywhere. They are the fundamental building blocks we use to predict and make sense of our world. We're talking about the code that runs your phone, the physics equations that launch rockets into space, the economic models that try to predict the stock market. All of it, every last bit, runs on the predictable, reliable power of functions.
So I'm going to leave you with this question to chew on. What relationship in your own life, maybe at work or just in your daily routine, operates with that same perfect predictability of a function, where one specific input always, without fail, leads to one specific output? It's a really powerful idea, and I bet now you're going to start seeing it everywhere. Thanks for joining me.